All right, torque. Let's torque about this one a little bit. Sorry, that was disturbing. Okay, what force acting at 32 degrees with a line perpendicular to the end of a 23 centimeter long wrench will generate 28 meter newtons of torque about the left side of the wrench? So we're generating torque about this side. Okay. So this is in the category of I give you the wrong angle and you got to figure out the right one. I think the simplest thing to do here is to figure out that the correct angle is actually this guy here, right? So it always needs to be, if you place these guys tip to tail, right? Okay. It's always that angle that you want, right? Okay. So if that's 32, then this one is 58. Is that right? Let's check that. Yeah, it is 58. That's 58 degrees. And that's the actual angle that we want to use in this, right? So torque is equal to RF sine theta, right? So we want 28 meter newtons, right? And then our radius is 0.23. Our force is, that's what we're trying to find. All right, and then sine of 58. Okay, now are you in degrees? Are you in degrees? Okay, because my calculator just wasn't, so let's try this. Okay, so I'm going to go 28 divided by 0.23 divided by the sine of 58 in parentheses, and I get 143.6 newtons. 0.55 newtons. There we go. We got it, man. Okay, so another interesting note is that I actually could have used this angle too, right? You just basically have to go from this angle to this one, right? Okay, so here they're drawn like that, but that angle would be, by the way, 122 degrees. That is, it's 90 degrees plus 32, right? Try that, just try it. Go 28 minus, and then change, instead of 58 degrees, make it 122. Indeed, you get the same answer, and that's because of the whole way sine works, right? Sine is the y coordinate, so anyway, yeah.